Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are still going to be discussing on structure and boarding. And for today, we are going to be looking at coordinate boards. So we are going to look at what a coordinate board is and then work on a few examples and end the session. So coordinate board is a special type of a covalent board. Now, when you look at the pair of shared electron, it's not coming from the two atoms equally. So the shared pair of electron is being contributed by only one of the atoms forming the board. Before we said that the shared pair of electron is being contributed by both atoms. But in this case now we can have a situation where we have two electrons or the pair that looks the same or like this. So it's being only shared or contributed by one atom. It's also referred to as dative board. So let's look at a few examples of how coordinate boards is formed, and then you draw the dot and cross structures together. So we'll start with the famous ammonium ion. We discussed about ammonium ion, which is a radical when you are forming chemical formulas. So you can see we have one nitrogen and four hydrogens. So we write that because you need it. So the first nitrogen is atomic number 7, which is 2.5. Hydrogen is 1, so configuration 1, 1, 1, and 1, 1. So there's an hydrogen I'm leaving out. I'm going to explain where it comes from in a minute. So normally you can see from the types of atoms we can see that we have a nitrogen at the center surrounded by 4 hydrogens. Like that. So the first thing, we try to work out what we have. So the first hydrogen here requires 1 electron, so it should be willing to share 1 electron. So it's left with none the moment it shares. The second electron requires also 1 electron, so it should be willing also to share 1 electron. So it's left with none when it shares. The third hydrogen requires 1 electron as well, so it should also be willing to give out 1 electron. It has nothing remaining. For the nitrogen, it's 2.5, so it requires 3 electrons to completely be full. So what we are drawing first, we will concentrate on the ammonia NH3 with 3 hydrogen first. So this nitrogen requires 3 electrons, so it should be willing to share those 3 electrons. How does it share? It shares equally with the 3 hydrogens that have shared something. So in the first, hydrogen is going to share 1, in the second, hydrogen is going to share 2, the second one, and the third hydrogen is going to share the third one. You notice when nitrogen shares these 3 electrons, it has 2 electrons remaining. So we shall call this one lone pair of electrons. They are lone. So these two lone pair of electrons are not left like that. What happens? They can still be used to contribute to the bond, which now we call the coordinate bond. How does it happen? So it happens when an ammonia gas reacts with an empty hydrogen or an hydrogen with 1 proton. So when you look at hydrogen, which is configuration 1, it can either gain 1 electron or lose 1 electron. So when it gains 1 electron, it becomes negatively charged. When it loses, it becomes positively charged. So what we are working with is an empty hydrogen that has reacted by losing that 1 electron. That is what is being included in this structure. So this 1 hydrogen requires, it has 0 electrons. For it to be full, it requires 2 electrons, but it has nowhere to nothing to share with. So what happens? The nitrogen decides to share those 2 extra electrons it had Remember we said it has 2 extra electrons. But now, remember it was positively charged, so when it comes in to be shared by nitrogen, it causes the whole molecule to be also positively charged. So when we present that with line, we are going to draw nitrogen surrounded by hydrogen around it. And then the first, it has a pair of electrons, so it is aligned. Next also has a pair of electrons, so it's aligned. The next also has a pair of electrons, so it's aligned. But when it comes to the one that is completely being contributed by nitrogen, we usually show with an arrow. And the arrow comes from the contributor to the one that is being contributed to. So the nitrogen is the one that is contributing 2 electrons to hydrogen. So we use an arrow. And that concludes our structure. So next, let's look at another example of a coordinate bond. So the next example is hydrozonium ion, and the hydrozonium ion comes from water that has reacted with an hydrogen ion. So you first draw water. Remember what we said. You can separate. This has 1 electron, 8. So configuration is 1, 1, 2.6. So if we draw that, we said the oxygen is going to be at the center, surrounded by 2 hydrogens. So the first hydrogen requires 1 electron, so it should share 1 electron. The second one requires 1 electron, so it should share 1 electron. And the moment they share that 1 electron, they are left with nothing. Oxygen requires 2 electrons, so it shares them equally amongst the hydrogens, so it remains with 4 electrons. So you can see it has 4 lone pair of electrons, 2 pair of lone electrons or 4 electrons. So they are free. So it can actually donate them to an hydrogen that is empty. So if we bring that hydrogen that is empty, the oxygen can decide to share its electrons freely. So if it shares again, it's remaining with 2 electrons. You show them down here. But remember the hydrogens we have introduced has a positive charge, so the overall compound becomes positive. So if you were to show that with line, it would be hydrogen and then oxygen. Remember this is oxygen and then hydrogen and then hydrogen. There is a pair of electrons in this hydrogen, a pair of electrons in the other hydrogen. But now the empty hydrogen is being contributed by the oxygen, so we put an arrow. And then we put the rest of the electrons that are remaining. And this is our final answer. Let's do one final question. So this one now is formed by reaction of a water molecule with an hydrogen ion and another hydrogen ion. So if we draw the water molecule as we had drawn before in the previous lesson, so this is how the water molecule looks like. So it's like that, the hydrozonium ion. It's like that, this ion. So the 2 hydrogens come from the water, but we have 2 empty hydrogens. But we know the moment oxygen that is at the center shares 2 electrons, it is 2.6. When it shares 2 electrons, it's left by 4 electrons. So we have 4 lone pair of electrons. 4 lone electrons or 2 pairs of lone electrons. So those 2 pairs can be donated to empty hydrogen. So it donates to this hydrogen and then it donates the other 2 to this hydrogen. So the overall charge becomes 2 plus because there are 2 empty hydrogens which are positively charged. If we were to present that with line, we have the oxygen, hydrogen, 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 hydrogen. These two, first of all, you put the pair of electrons, and then this oxygen is donating to this hydrogen, and it's also donated to this hydrogen. So this is your final answer. So let's do one final one and then we finish. So carbon 4 oxide, carbon, supposed to be carbon 2 oxide. So carbon 2 oxide is written as CO. So carbon 2 oxide, we have one carbon cycle, circle surrounding an oxygen circle. So carbon is 2.4, it's number 6, and oxygen is 2.6. So this is going to be interesting. For the first carbon, it requires 4 electrons. For the oxygen, it requires 2 electrons. So this is what we are going to do for the carbon that is on the top. First of all, we are going to share slowly. So it requires 4 electrons, so let's share the first 2 electrons. And then oxygen requires 2 electrons. The reason why I'm starting with the first 2 electrons is because oxygen requires 2 electrons. So it shares its 2 electrons as well. So the first 2 electrons in oxygen is done, we are left with 4. And then the 2 electrons, we remove 2 electrons, we are left with 2 electrons. So if we were to put the 2 electrons in carbon that are remaining and the 4 electrons that are remaining in oxygen, you notice they are not enough. Carbon is 1, 2, 3, 4, 5, 6. Oxygen is 1, 2, 3, 4, 5, 6, 7, 8. So it's only the oxygen that is balanced. So what you are going to do is you're going to have oxygen donate more, an extra pair freely. So oxygen is going to donate an extra pair of electrons. So when it donates, now it has donated 2 more, so it's remaining with 2. So it's donated 1, 2, 3, 4. So it remains with 2 electrons. And then the carbon atom donated 2 electrons, so it's left with 2 electrons. So now they become equal. So when we count is 1, 2, 3, 4, 5, 6, 7, 8, and for the oxygen is 1, 2, 3, 4, 5, 6, 7, 8. If we present with line, it becomes carbon. The first pair is a line. The second pair is a line because it represents 2. And then the next is an arrow showing that oxygen donated the third pair. So we put the rest of the electrons at the outside. And that forms carbon 2 oxide. So see you in the next lesson as we look at some of the properties of these compounds.